All right, so guys, today we're going to talk about how to find probability using Venn diagrams. And what we're going to do is we are going to start by filling in a Venn diagram, okay? Now, this is going to be a little tricky since you're at home, or you're not, yeah, you're at home and you're not here as far as telling me this. Now, what we're going to do is we're going to take all of you guys and we're going to look at two variables here. The first variable is going to be you're a senior or you're a not senior, okay? So I'm going to put in here, this is my senior, and that looks so bad, I'm sorry. And or you're a not senior. And our other variable is that you've gone to Disneyland or not. Okay, so now for me to be able to see everyone here, I might ask you to turn your camera on if that's okay. But raise your hand if you are a senior. How many total seniors are in attendance with me today? Okay, Casey's raising his hand, so I've got, and Rachel's raising a hand, nice. And Jordan. Okay, the others I know that you're seniors, right? Like, okay. You can put your hands down now. So if I'm looking at this group, the only person who's not a senior is Brandon. Is that, and Allie, right? Brandon and Allie, you are not seniors.
Yep, correct.
Okay. Now, so if I were to fill that in, I can't fill it in yet until I look at my Disneyland group. Okay, so seniors, I'm only talking to my seniors now. Who of you have not been to Disneyland? So, Jordan, are you raising your hand? Rachel lowered her hand, right? Or I don't know what's going on here. Rachel, are you saying you have not been to Disneyland? All right, this isn't working so well. So I'm just going to make things up, okay? I'm making this up as we're going. All right, so I'm going to, ooh, chat. You have not. Thanks, Rachel. Okay, so that gives me some feedback here. So I'm going to go back to my screen. And let's pretend, so of our seniors, let's pretend that there's 7 of you guys. And let's say that 5 of you guys have been to Disneyland, but then 2 of you have not. Let's say Rachel and Dimitri have not been to Disneyland. So they go on the outside. Everyone else has. Now, if we're looking at this other one, this is people who have been to Disneyland who are not seniors. So, Allie, have you been to Disneyland? Yes, no, you're frozen. I'm going to say that's, I think that was a no. So what we're going to do here is say that. That's a no. Okay, thank you. My computer, the internet seems to have slowed down a bit, so it's not working as well. So Allie, we're actually going to put in there as 6. Wait, no, sorry, that's 5. So Allie has been to Disneyland, but she is not a senior, so she doesn't go in there, right? And then Brandon, I don't know if you have or not, but I'm going to say you have not been to Disneyland. And so that's how we'd fill in our Venn diagram. So this circle right here represents those who have been to Disneyland, and this circle represents those who are seniors. And so this intersection, these are people who are seniors who have been to Disneyland. This group right here, this represents those who are seniors who have not been to Disneyland. And this right here, this is Allie. She is not a senior. She has been to Disneyland. And then on the outside, poor Brandon. He's just hanging out by himself. He is not a senior, and he has not been to Disneyland. All right, that's our quick intro to Venn diagrams. There's actually some pretty funny Venn diagrams if you do that. So now, here's what I want us to do, guys. Here is our data from before. Here's our two-way table. And what I want us to do is I want us to fill in this Venn diagram here based on the variable male pure steers. Now, this is going to be a little bit tricky because I need to know Here's how some people do this, and it's wrong, so don't fill this in. They'll look at this and say, okay, male, there was 103. And then they'll come here and then say 103. And then they'll say, all right, pure steers was 90. And then on the inside, that'll be male and pure steers, which is 19. Now I need someone to unmute and tell me why that is wrong. And I'm just going to sit here until someone unmutes and tell me why that's wrong. So somebody get on it.
Is it because they're counting 19 twice again?
Yes, thank you, Brandon. It is because we're doing that again. So the 19 is in the correct position, right? Because there were 19 who were males who had pure steers. That's correct. But then looking back at this, how many of our males did not have pure steers? 19 of the males had pure steers, but 71 didn't. So the total for the circle for males should be 90. So when I do 71 plus 19, I should get 90, but this says 71 did not have pure steers, 19 did. Okay, now same idea with the pure steers. 19 represents that for the pure steers, that was just the male. So how many not males had pure steers? And that would have been 84, so that if we add 19 and 84, we get 103, which is what the total was. Okay, oh, I need to admit Joseph, awesome. All right, now the last thing is we're not done yet. Someone unmute and tell me who is not represented inside those circles. Who would be like Brandon is on the outside of the circle?
Girls without pure steers.
Yeah, females without pure steers.
Awesome. The females without pure steers, which is how many? Just those 4. So I'm going to put 4 on the outside. These represent the females, so they are not male, and they don't have pierced ears. All right? So one of the skills you need to have is to be able to take information and to put it in a two-way table or to put it in a Venn diagram. And we like this because now we can figure out probabilities here, okay? So when I'm looking at this Venn diagram here, and this will kind of show us some different ones here. Let's just read through this. General addition rule for 2 events. We can't use the addition rule for mutually exclusive events unless the events have no outcomes in common. When I'm looking at this Venn diagram, do they have things in common? The answer is yes, they have that overlap because you could both have pierced ears and be a male. There's an overlap there, right? And so that this gives us this new formula. This is our general addition rule. So for any 2 events, you can find the probability of event A or event B by taking the probability of event A, adding probability of event B, and then subtracting the overlap. Okay? So what that's saying here is, let's say we wanted to find, just go back to the example, we've already done this like 3 times. What's a probability that is male or has pierced ears? Well, we're going to look at the probability that they're male, plus the probability they have pierced ears, and then subtract off the intersection. So the probability that they're male, that was 90 out of 178. The probability they had pierced ears was 103. But we said the problem was we would count that overlap twice. So then if I subtract that overlap of 19, then that will give me the correct probability, which I believe was 174 out of 178. Awesome. So that is our general rule for 2 events. Now, someone might say, well, what if they are mutually exclusive, meaning they have no overlap? Well, then the probability of A and B is 0, and so it's just back to the formula we learned last time. Okay, this is when I pause and I say, do you have any questions up to this point? And so you can either like unmute and just shout it out or raise your hand. Any questions, guys? Are we good? Awesome. We're going to keep going then. Let me know if, was that someone saying we're good? Cool. We're going to keep going. All right. So now here are just a couple of things when we're working with Venn diagrams here, okay? Because Venn diagrams have uses in other branches of mathematics, some standard vocabulary and notation has been developed. So we talked about the complement last time. And the complement was the opposite. So if the probability of me rolling a 2 is 1 out of 6, the probability of me rolling not a 2 is 1 minus 1 out of 6, which is 5, 6, right? Well, if we're looking at a Venn diagram, let's say this is probability of A, the complement of A, the probability of the complement would be everything not included in A, so it'd be the outside of that. Sorry, I didn't mean to do that. Okay. The events A and B are mutually exclusive, also known as disjoint, because they do not overlap. That is, they have no outcomes in common. That means they look like a VHS tape. Do you guys even know what a VHS tape is? Like, this is what I grew up on, but you guys know what those are? All right.
I have Power Rangers on VHS.
Awesome. VHS is awesome. Now, see how it looks like a VHS tape? So 2 circles that aren't overlapping. That means they're mutually exclusive, which means there's no overlap. Okay? Let's keep going. Here's 2 other ones. The intersection of events A and B is notated by this A and B. It's this N for and. Okay? That's how I remember A and B. And that's just where they intersect. The N is for intersect, or the N is for and, or whatever, okay? But it's where they overlap, which is that green section right there. And then when we're doing A or B, we do this U, and the U is for union. That means they could be, U for union means it's in A or B, and if it's in both, then that's one of them, right? So we're good. So to keep this straight, just remember the U is for union. It means they've been joined together, and it could be one or the other or both, okay? And then the N is for intersection, which means it has to be on the middle. Okay? All right, let's come over, let's look at an example here, okay? So let's look at these 4 right here. We're going to kind of do it. I think normally when oh, wait, let me try this. Wait for it, okay? All right, so we filled it in and it looked just like that, right? Now, oh, never mind. I thought I'd give it 1 at a time. Whatever. Okay, let's just make sure we understand what's going on here. So when we're saying A intersect B, the N is for intersect. This is where they overlap, and it's going to be the 19. Now, what is this saying? A intersect the complement of B. So this is when I'm saying, here is B, and I want everything outside of B. Okay? And we're going to say, where does A intersect with everything outside of B? And it's kind of hard to visualize. Usually what I do is I kind of draw it in. So maybe actually let me come back here and let me see if I can draw it in. What I would do is if I would say, okay, if I am going to, here is B, and so to do its complement, it's going to be everything outside of it, okay? And then I'm saying, where does that intersect with A? Well, A is right here, and I'm going to shade it in. Now, where do I see purple and orange together? It's just that 71. But that's how you'd find the intersection of A and the complement of B. Okay? And then we get to erase all that fun stuff. Let's do another one. Let's do, where does A complement intersect with B? So then I'm going to take the complement of A, so I'm going to circle A right here, and I am going to everything outside of A. And I'm going to then look at B and say, where do those intersect? And you could see it would just be those 84 right there. Okay, now I'm going to give you guys 15 seconds here. You're going to look at the complement of A, and the complement of B. And I know the answer is there, but just try to visualize what would that look like, okay? So I'm going to give you 15 seconds. Think about it. All right. And
It's so glitchy.
say that again, Allie.
My thing is so glitchy. I can still see you drawing on the board.
Oh, did it not erase for you?
No, it did. It's just like still drawing because it's so like glitched out.
Oh, I'm sorry it's
So
glitched out.
it just barely just erased it.
Okay, hey, let me try something with you guys, okay? I'm sorry if it's being glitchy, but let's try this. I know I said not to do this, but can you guys mute your videos? Not just your sound, but your videos. I wonder if it's trying to like, I wonder if it's, I'm gonna stop sharing here. Let's go back here. I wonder if it's trying too hard to like keep up to speed with everyone's videos, that it's slowing down the other stuff. Do you guys know how to do that? Just find where your camera is and mute your camera. Sorry, I like seeing your faces. It makes it more personable, but I think it's glitching it out. We'll see if that's any good. Let me see if I can. Okay, cool. All right. So I hope that helps. Maybe you can unmute and tell me if that's any better. I don't know, guys. I'm just making the best of this. Okay, so now let's go back to sharing the screen. Hopefully you guys, as you were going through that, you said, okay, the complement of A is everything outside of A, and the complement of B is everything outside of B. Where do those intersect? And it's just going to be on the outside, which was the 4. All right. Do you have any questions from those guys?
No.
Cool. Thanks for the feedback. Okay, we're going to do one together, and then you're going to do one on your own, and then that's it. Okay, pretty cool. So let's look at this. We've seen this before. This is the homeowner Venn diagram. So I'm looking at this homeowner Venn diagram. And what I want you to do is I'm going to give you 30 seconds. I've made 2 circles. This first circle is for people who graduated high school. The second circle is for those who are homeowners. And what I want you to do is to put the numbers in the right spot so that this Venn diagram illustrates what's going on in this two-way table. And if you need to kind of on a different paper or something, draw this out real quick. I think this is in your alternate examples if you have your notes. But I'm going to give you 30 seconds to try to fill that in, okay? 30 seconds, go. Oh, great. Could you guys hear the Jeopardy music?
Yes.
Awesome. Hey, Casey Nash, since you answered, I know you can hear me. I'm going to have you tell me how you filled this in, all right?
Okay, deal. So in the intersection, what is the symbol called again? What is the little N?
And.
Oh, okay. So for A and B in the middle, it would be 221, right?
Yep.
And then for the A and B complement, the complement of B or whatever it is, it would be 89.
Right there. Is that what you're saying?
Yep.
Great. Keep going.
And then just the owner side would be 119. And then outside would be 71.
Nice job, Casey Nash. That would be an
Yeah.
accurate representation. Now, what I'd want you guys to do at this point is then you would, for each of these, you would try to like put it into the context of the problem. So for example, A and B is a 221. What does that mean? Well, that means they are a homeowner and a high school graduate. So right here in this part, I'm not going to write it because I have really bad handwriting and it's too small space. But I would write there, they are a homeowner and a graduate, and that count was 221. All right, so then I'm going to go to Allie. What does this mean, the inside circle A but outside circle B? So that's 89. How would you, Allie, say that? What does the 89 represent in the context of this problem?
It represents graduates that aren't homeowners.
Awesome. Okay. So that's going to be the 89, and you'd write a little blah, 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 blah right there, okay? All right, and then, so then I'm going to go to Brandon and say, so Brandon, what does a 119 represent in the context of this problem?
That they're homeowners but not graduates.
There you go. And then lastly, we'd have those 71 who are neither. They are not homeowners, they are not graduates. And there you go. Now, one thing to keep in mind is this is using A's and B's. So you might need to, like, if you're going to be using this notation, you have to define which one does A refer to, which one does B refer to. All right. Okay, let's go to our last problem here. Cell phone versus landline. Now, keep in mind, this was data from 2008. So that was 12 years ago. Things have probably changed since then. But this is what we're going to do here. So according to the CDC, or wait, no, not CDC, National Center for Health Statistics, in December 2008, 78% of US households had a traditional landline, 80% of households had cell phones, and 60% had both. Suppose we randomly selected a household in December 2008. Part A, make a two-way table that displays the sample space for this chance process. Part B, make a Venn diagram. Okay, so what you're going to do is, if we refer to this last example, here is a two-way table, and then here's a Venn diagram. The difference this time is, instead of doing homeowner and graduate, we're doing cell phone owner and landline owner. Cell phone owner and landline owner. So what I want you to do is, we're going to make a two-way table here. And this one right here, this is going to be, let's do this one as a cell phone first. I'm going to do cell, a Y for yes, cell and N for no. And then I'm just going to put LL for landline yes, landline no. Then you're going to do a Venn diagram, and this is going to be cell phone, landline. And I want you guys to fill those in with the appropriate numbers. I'm going to give you 2 Jeopardies, okay? So go ahead and start filling those out, and then I'm going to call on someone after 2 Jeopardies. All right, now this one was a little bit trickier than the last one, but is there someone who thinks they got it? Does someone want to unmute and tell me what your thought process was for filling in either of those?
Oh, sorry. So would the 78% of households who had a traditional land phone go in the LLY and then cell N category? Since they have a landline but they don't have a cell phone, so that would be 78%. But how would you? Because I mean, there's no set amount of
So
number of.
that's a good question right there, right? So what I'm going to do is I'm going to actually add one more column here, which is going to be total. So I'm going to put T for total. So that's 78. If I'm doing 78% of these people had a traditional landline, that's going to be the total for those who had a landline. So landline total is 78%. So that 78 is kind of coming down here. Now, what will our total, this one here, what is that going to be? It's 100. So they told us 78% have landlines, so we can use a complement rule. How many will not have a landline?
22.
Awesome. So that's how we're going to use that. Cool. So Ashley, I'm going to have you keep going then. So then if 80% have cell phones, I'm going to put 80 there. What goes right there?
20.
Okay, cool. So we're kind of filling in our two-way table for the totals, but we don't have any of the inside, except which one do we have?
Sorry, my.
You are good. Don't worry about it.
It says that 60% have both.
All right, so that's going to go in. They have a yes and yes. So the 60 goes there. Now, does that 160 give us enough information to fill in the rest?
Yes.
Yeah, because how do you get from 60 to 78? What does that mean? People who have a landline but don't have a cell phone, what does that mean this is?
18.
Awesome. And then from 60 to 80?
20.
And then here, this one, I'd have to go from 18 to 20. What are we going to get?
Oh, 2.
Yeah, or from 20 to 22. Now I've got to check, do these add up every way? And they do. And that means, boom, we've got it. Thanks, Ashley, for your help there. That's how you'd fill out the two-way table. You've got to use your total. So cool. It was a little tricky, but we got through it. Now, give me someone different. How can I take that to fill in my Venn diagram?
Could I do it?
Yes, please go ahead.
All right. So first off, I like doing this section where it has both of them. So we're gonna put that 60% in the center of the two circles, and then for the exclusive landline, that would be 18, and then the exclusive cell phone would be 20, and then the outside section with neither would be 2.
All right, let's check that. What should all of those add up to, guys? It'll be 100. So
100.
100. Good job. Now let's check. So total cell phone is 80%. Total cell phone 80%. Great. Total landline 78. Great. Both is 60. Cell phone no landline 20. Landline no cell phone 18. Neither 2. Boom. There we go. So that's how you do that. Nice job, Joseph. So then now we can answer a question. Find the probability that the household has at least one of the two types of phones. At least one, that means, look, we're going to put it like this. This is a probability that they are a cell phone. And then would we put an or landline or would we put and landline there? If it's at least one, it could be one or the other. So we're going to do or. So the probability is cell phone or landline. Okay. So what's that going to be? Well, I'm just going to add up those three on the inside, the 20, the 60, and the 18. Or if you wanted to use what we learned from before, you could add up the 78 and the 80, but then you'd have to subtract off the 60, right? But if we just add up these right here, that gives me there's a 98% chance that they've got one or the other, because only two don't have a cell or a landline. Okay. Lastly, on part D, find the probability of the household has a cell phone only. Just shout it out, guys. What was the percent that was cell phone only?
20.
Good job, Casey and Joseph. So 20%. So then that would be 20%. All right. So now this wraps up 5-2. So we've talked about the probability models, basic rules, complement rule, mutually exclusive, how to use a two-way table and Venn diagram, and the general addition rule. So your assignment is 5-2. We've got these problems here. Not a whole lot of problems, right? And notice that they're all odd, which means you can check your work in the back of the textbook when you're done. But notice the emphasis there needs to be check your work. Don't go there and just peeking for answers you won't learn. And then thought of the day, positive thinking will let you do everything better than negative thinking will. So try to stay positive out there. So let me jump back to this. Do you guys have any questions before we wrap this up?
I have no questions.
Okay. Well, cool. Go and we're going to end this right now, and that gives you like another 45 minutes here. So you can go get started on the reading guides, go get started on the homework questions. And if you get stuck, please email me. We'll be tuning in for something like this again on Thursday as we dive into 5.3. 5.3 will probably take 2 days, and then we'll do a review and test. So make sure you're staying up to speed and let me know if you have any questions. Big thank you for tuning in. I hope it was helpful. We'll see you guys on Thursday, all right?
See you,
care,
Silver.
folks.
Cool, thanks.
See you
Thank
guys.
you.